Chapter 7's essential question is, why are algebraic used? Chapter 7's essential question is, why are algebraic rules useful? It's similar to asking the question, why are football rules useful? Or why are safety rules useful? In this case, we're talking about the rules that go along with algebra. In this lesson, you're going to be able to use the distributive property to write equivalent numerical expressions, and you're also going to be using that distributive property to write equivalent algebraic expressions. So just as a reminder, numerical expressions involve numbers and operations, and algebraic expressions involve numbers and variables. So looking down lesson 7.1, you have two vocabulary words, equivalent expressions and distributive property. And a key concept there in symbols, when you have the distributive property with a variable or a number out front, in this case the A or the 5, you distribute that to everything inside of the parentheses. The same works with if you're going to subtract something inside the parentheses. You distribute what's on the outside to what's on the inside. Okay, it's pretty straightforward, and the reason that works is if we actually substitute in numbers for it, like 9 minus 3 times 8. Well, if we did order of operations, 9 minus 3 is 6, and 6 times 8 is 48. And that's the same thing as 8 times 9, which is 72, and 8 times 3, which is 24. And 72 minus 24 is also 48. Going down to bottom on example 1, it says to use the distributive property to write the expression as an equivalent numerical expression. Now you might want to just jump right into simplifying this and saying 6 plus 3 is 9, 9 times 4 is 36. But what it wants you to do is distribute that 4 to the 6 and the 3. So we have 4 times 6 plus 4 times 3. 4 times 6 is 24, 4 times 3 is 12, and 24 plus 12 is 36. Again, the same answer we got by using the order of operations, but in this case we are wanting to write out those steps. On 1b, we're going to distribute the 3/4 to the 9 and the 2. 3/4 of 9. Don't let these scare you here. Sometimes those fractions throw people off. So 3/4 times 9 is 3/4 times 9. And then 3/4 times 2 would be 3/4 times 2. And remember that those numbers are just over 1, so we can multiply. 3/4 times 9 over 1 is 27 over 4, and then minus 6 over 4, and 27 minus 6 is 21 over 4. So you could leave it as 21/4. Of course, you could simplify that to 5 1/4. So again, with numerical expressions, you can follow the order of operation, but this is just showing that the distributive property is one more way to simplify a numerical expression. On page 293, example 2, we're looking at a story problem, and again, not saying that writing it out with an expression or an equation is the only problem-solving strategy to use, but this is the focus of this chapter and this section, so we're going to practice using that, okay? And so on example 2, remember that you do have access to some video tutors. That's just someone else explaining the problem to you, so don't forget that you can access those if you need a little extra help. You can read through this example here and follow the steps to make sure it makes sense to you. Right now we're going to work out 2A and 2B. So a spaghetti dinner at the Italian Village restaurant costs $10.25. And it wants us to use this strategy. Again, there's other strategies to use when solving this type of problem, but we are going to use the property to just see how it works. Okay, and then use mental math to find the cost of the dinner for Sharita, her brother, and her parents. So that's 3 people. So again, you might be thinking, I could take $10.25 times 3 a lot faster than what you're going to show me here with the distributive property. But again, play along with me here. We have 3 people, and then we can break down $10.25 to $10 plus 25 cents, okay? And we can distribute that and say 3 times 10 is going to be $30, and 3 times 25 cents is going to be 75 cents. And so we have the total cost of $30.75, okay? After dinner, they each order a gelato for $10.50. What's the new total? Again, you could just multiply that out and find the answer, but what you could do for distributive property is take 3 times $1.50, which could be broken up into $1 and then 50 cents, okay? And so we have 3 times 1, which is $3, plus 3 times 50 cents, which is $1.50, and we have a total of $4.50, okay? Again, not the only way to solve problems, but this distributive property can be used to break up problems into smaller ones so that you can do them mentally. So now we're moving into some algebraic expressions. And remember, the difference between numerical and algebraic is that there are variables involved. And there's one method here using algebra tiles as a way to show how to do this. And so right here we have an x and then 4 singletons, and we have 2 sets of those. So this just means we have 2 sets of x plus 4, okay? And if we break that up, we have 2 x's and we have 8 ones. So 2 times x is 2x, 2 times 4 is 8. So the final equivalent expression is 2x plus 8. Okay, so we're still going to distribute what's ever outside to the inside, but in this case, if we have a variable, the only thing we can do is write that as 2x. So moving on to page 294, we're going to look at example 3 at the top of the page, 294. And in example 3, we are going to use the distributive property to write an expression as an equivalent algebraic expression. So we're going to take 2.4 in 3a. We're going to take that 2.4 and distribute it to everything inside of the parentheses. So 2.4 times a, we are not going to write that as 2.4 times a, right? Because we can't use that x for multiplication. We're just simply going to write 2.4a. And then 2.4 times 5. What's 2.4 times 5? We're going to put 0, carry the 2, and we get 12. Okay, so that is the final simplified, or another way to write that algebraic expression, the equivalent. Okay, if the 3 or the number is on the outside of the parentheses on the other side, it's not a big deal. You just still distribute that to what's on the inside. So 3 times b is 3b, and 3 times 6 is 18. So 3b plus 18 is that answer for 3b. Finally, we're going to be doing a few more of these problems of distributing what's on the outside to the inside. So in this case, 2/3 times d is simply 2/3 d. And then 2/3 times 3, we're going to put a minus sign there, and we're going to get -2. And finally on 4b, -7 times e is -7e. -7 times -4, or -4, would be a +28. This is where you're going to make your mistakes. You're going to forget those negative signs, and then that's going to change your answer and make it wrong. So just make sure to pay attention to negatives as you are using the distributive property. On your note sheet, we are also going to look at a few more problems, and I would like for you to look at page 296, the HOT problems, H-O-T, which stands for higher order thinking. And I wrote down to look at number 37. It says, find the error. Julia is using the distributive property to simplify that problem there. What did she do? She took 3 times x to get 3x, but this is a very common mistake. She forgot to distribute the 3 to the 2 as well. This 2 right here should be a 6. And then on number 38, it says, is this algebraic expression equal to this algebraic expression? True or false? So one way you can prove this is just by coming up with a value for x and y. So let's just say x is 2 and y is 3. Okay, so let's put those numbers into this algebraic expression. X is 2 and y is 3. X is 2 and y is 3. So let's simplify this side of the equal sign by doing parentheses first. 2 times 3 is 6. 6 plus 3 is 9. On the right side, if we simplify, we have 3 plus 2, which is 5, times 3 plus 3, which is 6. 5 times 6 is equal to 30, so they do not equal each other. So when you're finding out whether something's a true statement or not, really you only have to come up with one false example to provide a counterexample. So number 38 is false, and a counterexample would be if x is 2 and y is 3. Go ahead and make sure you take your online self-check and do the homework practice problems 2 through 38 evens. Make sure to correct those and put the answer or the number correct at the top of your page. There are a couple IXL lessons for you to get through for 7-1, and there's an ed puzzle on the distributive property. There's no notes to take for that one. It's a really quick one by Schmoop. And then there's a brain pop video and quiz on the distributive property for you to watch and take a quiz on.